Okay, guys and girls, so today we're going to go ahead and continue on with a few new identities. At this point, we're going to continue to just evaluate trig functions, which means we're going to try and find a missing trig value when we're maybe more than one, but we're going to be given some information about other trig values. So today we're going to do the Pythagorean identities, which, if you're looking at your cheat sheet here, are sine squared plus cosine squared equals 1, tangent squared plus 1 equals secant squared, and also cotangent squared plus 1 equals cosecant squared. And the reason they're called Pythagorean identities is because they look kind of similar to that a squared plus b squared equals c squared. Okay? The other two we're going to look at are cofunction identities, which the cofunction identities kind of focus on that whole idea that sine and cosine actually look really similar. If you remember what their graphs look like, they're really similar, but they're just kind of shifted a certain distance away from each other. And we can use that information in order to come up with these identities, such as sine is equal to cosine of pi over 2 minus theta, and so on. And then we also have our even odd identities, and that's just that if we have a negative out in front of a function, right, and also a negative inside our function, they can actually end up giving the same exact function. So, for example, sine of negative theta is the same exact thing as sine of theta, negative sine of theta. And some of these guys work a little different. For example, cosine, if we have cosine of negative theta, we actually have the same exact thing as cosine of theta. Just got to keep an eye on all those. But these will all be available to you for any quiz or work I give you, so don't be too afraid. I know it's a lot of info. Okay, so first we're going to look at the Pythagorean identity and how we can use it. So you'll notice that we have these squares, and all those guys mean is that we're going to take our cosine value or our sine value, whatever value we have, and we actually square it. Right? So if you take a look at number 4, the information we're given is, we said it's asks us to find cosine and tangent if sine is equal to negative 1/3 and cotangent is less than 0. So the first thing we actually want to do here is we want to figure out what quadrant our angle must lie in. The reason why is because that's going to have an effect on whether our answers are positive or negative, right? So the two pieces of information we know is that sine is negative, so that means we can't be here and we can't be here, right? And we also know that cotangent's negative. That means we can't be here because cotangent and tangent are both going to be less than 0. So we're going to be quadrant 4. And remember, that'll tell us our signs once we're done figuring that out. Right? So what we're going to use is we're going to use these Pythagorean identities to find cosine and tangent. So first I'm going to go ahead and try and find cosine. If we look at our Pythagorean identities, the one that has cosine and sine in this case involved is this first guy right here. So I'm going to go ahead and do cosine squared plus sine squared is equal to 1. And the thing I already know is sine, right? It's negative 1/3. So I'm going to go ahead and do something like this. I'm going to do cosine squared plus negative 1/3 in parentheses squared is equal to 1. Okay? And I'm just going to continue until I can actually solve for cosine. So I have cosine squared plus 1 over 9 equals 1. I got to get cosine by itself, so I'm going to subtract 1 over 9. This is going to happen quite a bit. You're going to have to rethink of some values here in order to get a common denominator because we're subtracting a fraction. So I'm going to think of this 1 as 9 over 9, right? That's the same exact thing as 1. So 9 over 9 minus 1 over 9 is 8 over 9. And then to finish off, that little squared, we get rid of that the same way we've gotten rid of squareds when we just had an x there. We just take the square root, and we're going to have cosine is equal to, I'm going to have the square root of 8 over 3. And I took the square root of 8 and I took the square root of 9, we actually know it's just 3. And then I'm going to continue on, and I'm going to simplify that down. Square root of 8 is 4 times 2. And that's going to give us 2 square root of 2 over 3. Finally, you're going to decide whether it's positive or negative. Because we took the square root, we have both options available to us. But we know we're quadrant 4, so this guy is going to have to be positive because remember, cosine is the only positive in quadrant 4. So there's cosine. The other guy we're trying to find is tangent. Okay, so what we have to do here is we have to figure out first which Pythagorean identity we're going to use. I'm going to go ahead and use the one that has tangent in it. Okay, and then I'm going to go ahead and write it out and plug in everything I know. At first glance, it looks like we don't know anything. But what you should realize is because we actually have secant squared here, we can actually go ahead and we can take cosine and just flip it and plug it in right there. Okay, so check it out. I'm going to go ahead and do tangent squared plus 1 equals, I'm going to flip this guy, okay, to get secant. That's going to be 3 over 2 root 2 squared. Okay, so all I did there to figure out what secant was take cosine, which I just found, and I flipped it. Remember, those guys are reciprocals. And now let's continue on. So I'm going to have tangent squared plus 1 equals, I'm going to square everything in here. So my numerator is going to be 9. And down on bottom, I'm going to have to square this 2 and square the square root of 2. So that's going to be 4 times 2. I'm going to get something like 8. Right? Then I'm going to go ahead and I'm going to subtract 1 on either side here. Once again, I'm going to have to rethink of this 1. I'm going to rethink of it as 8 over 8 in this scenario. Right? Remember, that's the same exact thing as 1. I'm going to pop up here now. I'm going to get tangent squared is equal to, that's going to be 9 over 8 minus 8 over 8 is 1 over 8. And then to get rid of the square, I take the square root. I'm going to have tangent equals, square root of 1 is just 1. And the square root of 8, right, I'm going to actually harken back to over here. We already broke down the square root of 8, and it went from square root of 8 to 2 square root of 2. So I'm going to rewrite this as 2 square root of 2. And then finally, to finish off, I'm going to go ahead and rationalize. Remember, we can't have a radical in the denominator. Right? And I get something like square root of 2 over 4, it looks like. Right? I still have to decide whether this guy's positive or negative. So looking at my quadrant 4, cosine and secant are the only positives there. So this guy is actually going to be a negative. So there's a negative out in front of that. And that's all we had to do there. Okay, so now let's take a look at number 5. And actually, if you guys want to go ahead and try it, you can pause the video, or if you're not feeling confident enough, you can just go ahead and follow along. So here we're trying to find tangent and sine, and we were given secant is 6 over 5, and sine is greater than 0. So first off, apple sandwiches taste crunchy. We're going to decide which quadrant we're in. So secant is 6 over 5, which is positive, which also means that cosine will be 5 over 6, right? Those guys are reciprocals. That might help us out later as well. So if cosine is positive, we're either going to be in quadrants 1 or 4, right? And we also know that sine is positive, so that means can't be there. We're going to be quadrant 1. And remember, all we did that for was to make sure that once everything's all said and done, we can decide which sign our trig functions are going to have. So first, let's go ahead and figure out what tangent's going to be equal to. So if we take a look at our Pythagorean identities, this one definitely has everything we need. So I'm going to do tangent plus 1 equals, and then instead of secant, I'm going to put what secant is equal to, 6 over 5, and I'm going to square it, right? And I'm going to just solve for tangent now. So 6 over 5 squared is 36 over 25. At this point, you should be getting pretty good at rewriting with the common denominator. When I'm actually subtracting 1, I'm going to rethink of that 1 as 25 over 25. And I get something like, I believe that's 11 over 25. And now I'm going to take the square root, and that will give me the square root of 11 over 5. This guy's going to be positive because we know our angle lies in quadrant 1. Okay? And then to figure out what sine is equal to, I'm going to go ahead and use my first Pythagorean identity, cosine squared plus sine squared equals 1, because earlier we just figured out what cosine was real easily by just flipping that guy. Okay, so I'm going to go ahead and do 5 over 6 squared plus sine squared equals 1. So I remember all I did was I just rewrote my Pythagorean identity, but I plugged cosine in. So that's going to be 25 over 36 plus sine squared equals 1. So first I got to get rid of that 25 over 36. And I got to rethink of this 1 as 36 over 36. So this guy's actually going to be 11 over 36 when I subtract the 25 over 36 from it. I take the square root, and it looks like sine should be the square root of 11 over 6. Also positive because we're in that first quadrant. All these guys are positive. Right. So the identities that we checked out right there, and then also on that front page, are going to be, sorry, not the front page, on our first page of notes here, quotient identities, reciprocal identities, and Pythagorean identities are going to be by far the ones we use most commonly. Right? I'm still going to show you one example here and give you 2 homeworks on it. These ones aren't too tough, okay? And it's kind of a similar process, but these are our cofunction identities and our even-odd identities. So if you take a look at number 6, right, it says if sine of negative theta equals negative 0.97, find cosine of pi over 2 minus theta. So these ones, the way I like to think about, I think about what I'm trying to get to, and then I check out how I could use that to get back to where I am right there and what I was given to start with. So cosine of pi over 2 minus theta is that right there. Okay, so I know that that is actually equal to sine of theta. So if I could get this guy to somehow be rewritten as sine of theta, then I'll be able to find this very easily. I can just substitute the two, right? So for this one, sine of negative theta, if I look at my even-odd identities, I know sine of negative theta is actually equal to negative sine of theta. Right, so all I did was take this guy and rewrite it as negative sine of theta. And remember, what my goal was to get sine of theta by itself. So if I just divide by negative 1 on both sides, remember this is an equation. As long as we do something to both sides, right, it's all good. So that changes it to positive 0.97. And now, like we mentioned earlier, we know that cosine of pi over 2 minus theta is actually equivalent to sine of theta. So I can just take this sine of theta and replace it with exactly what we want to find. And I got my answer. The cosine of pi over 2 minus theta is equal to 0.97. Okay, so what I want you to do to practice here, you're going to do numbers 5, 6, 7, and 8. They're all Pythagorean identity. And then I want you to do numbers 9 and 11. 11 is a bit of a challenge problem, so if you get stuck, you can remember you can always access the homework answers and you'll see the work for that one there. I hope you guys have a great day.